Hello! Welcome to the second video for section 5.3 video podcast for the flipped lesson for solving quadratic equations by finding square roots. The first video we talked about finding square roots. This one we're actually going to use square roots to solve quadratic equations. We're going to solve the real life part for class, but that is our second objective, our second goal for this section. So let's take a look at what's going on. See, here I've got a quadratic equation. It is quadratic because of this squared on the x. Yep. When we have a single x, and that x is an x squared, I don't have an additional x term in here that is a first degree or anything else. What I want to do is isolate that x squared term. Isolate, meaning get it by itself. So that's what I'm going to do. I'm going to get that x squared by itself. So I'm going to take away the 3, leaving me with a negative 5x squared equals negative 12. Then I will take and divide by negative 5. Divide by negative 5. That leaves me with x squared being equal to 12 fifths. That means that x could be a positive square root of 12 fifths or a negative square root of 12 fifths. Because either one of those, if I were to square them, when I put them back in for x, would come out to a positive 12 fifths. Throw on the brakes. What are you talking about, Mr. Syverson? Let me show you. Let's go off into our imagination bubble. And let's think about the simple equation x squared equals 9. Now, what are the solutions to x squared equals 9? You there in the first row. Yeah, what? Tell me, what could the values of x be?
Well, let's see. X has to be 3, obviously.
Half right and half wrong, because x could be negative 3 as well.
What?
Yeah, if x was negative 3, if I squared x, it comes out as 9. Just like if I squared x on this side, that comes out as 9. So really, to save us the time and trouble of all of that, I'm just going to write x equals positive and or negative 3. So I'm going to do that over here. I'm going to take the square root of both sides. And that leaves me with x is equal to the positive or negative square root of 12 fifths. Now remember back to our last video, and we had that quotient property. I can bust this up into x equals the positive or negative square root of 12 over the square root of 5, which then gives me x equals positive or negative square root of 4 times 3 over the square root of 5, which is then equal to, lots of simplification here, positive or negative 2 square roots of 3 over the square root of 5. Are we done? No, we're not. Just as we discussed in the last video, I cannot divide by an irrational number according to proper math etiquette. So let's go ahead and divide the top and bottom by the square root of 5. What that then gives me is that x is equal to positive or negative 2 square roots of 15 over 5. Done. That is my answer. Both of those are possible answers. Of course, we would want to go back and plug those into our original equation to check out if they work, but I'm telling you right now they do. Okay? So, that is our first experience. That is if I have a single x value, and that being x squared, not 2 of them in there, just 1. All right, let's keep moving. This one, Ah, this is a doozy. This is wonderful. Here I've got 3 times the quantity of x minus 2 squared equals 21. Reverse order of operations. PEMDAS backwards. SAD MEP. When we're solving equations, this is what we want to do. Okay? We get rid of addition and subtraction, then we get rid of division and multiplication, and then we get rid of exponents, and then we get rid of what's in parentheses, left to right. So, the only addition or subtraction going on over here with the x is inside parentheses, which has to be handled last. So then I go on to my next pairing, division and multiplication. I'm multiplying by 3, so I'm going to go ahead and divide both sides by 3. So that gives me x minus 2 quantity squared equals 7. Now, just like in the last slide, when I take the square root of both sides, I'm going to have to do positive or negative square root. So this leaves me with x minus 2 equals the positive or negative square root of 7. Because when I square either of those to get back to this line, I come out with positive 7. Then I will add 2 to both sides, add 2, giving me x equals positive or negative square root of 7 plus 2. Now, to obey standard mathematical conventions, get your answers to match those in the back of the textbook. And just because it looks cool, we are going to apply the commutative property of addition and move the 2 in front of the positive or negative 7. So we get x equals 2 plus positive or negative square root of 7. A lot of people, just FYI, are going to write this as 2 plus or minus the square root of 7. That is the answer, my friends, right there. All right. Now, real quick, I want to give you a heads up. This problem may present itself in a more complicated looking fashion. Yeah. You might actually have this in a whole nother format where it's presented as an unfactored quadratic. If you have that, you're going to just do the factoring and then solve like we've done in our other chapter. Okay? So, but if we present like this, follow this method. We present like this with just this x squared by itself, solve in this method. Okay, there we go. All wrapped up. Enjoy. Get ready for class. We're going to have a good time. Peace out.